As we start Unit 3, Expressions, Equations, and Inequalities, we're going to work in Module 6, which breaks that up into expressions and equations, and then Module 7, which works in inequalities. In this unit, then, we're going to work on writing two-step equations to represent real-world problems, and then also write a real-world problem from a two-step equation. Learn how to go back and forth between those, addressing the standards. Some background information that we need then to help us out in understanding what we're going to do. I have here on this screen the commutative property of addition, the associative property of addition, and the distributive property of. So if we go in here and we look at the commutative property of addition, if I use the example of 2 plus 3, that means that we can simply take these two numbers and we can reorder them, and so that equals 3 plus 2. So our answer is going to still be the same. 2 plus 3 is 5, 3 plus 2 is 5. In the associative property, so let's say we have this grouping 2 plus, and then we have 3 plus 4 is grouped together. So our order of operation tells us that we have to do the 3 plus 4 first because it's in parentheses. So that would be 7, and then 7 plus 2 would be 9. But the associative property for addition allows me to regroup. So if I take the 2 plus 3 and I group that and plus 4, so this now becomes 2 plus 3 is 5, and then plus 4 would be 9. So I still come out with the same answer, but the associative property of addition allows me to regroup that. These two are going to be important concepts to use as we go and learn the distributive property. So if I have this example of 4 times 3 plus 2, what that means is that when I simplify this, I'm going to take my 4 times 3, because remember this means to multiply. So if I rewrite that as another expression, 4 times 3, okay, that's one group. And then I take the sign right here, which is addition, so plus. And now I take the 4 times 2, so that becomes 4 times 2, and that is my other group in my distributive property. So what I've done is I've simplified this, 4 times 3 plus 4 times 2. So this is called factored. So if I looked at this here and I go the other way, I can see that my 4 is common here and here. Okay, so I could factor those out. So I take that and I put the 4 on the outside, okay, and then I bring in these terms. I have the 3, I use this symbol, the addition, plus, and then I use the 2, and that's what I left with. So I have the same thing. This is now factored. So 4 times 3 plus 4 times 2. So this is how we're going to use the distributive property and go back and forth. So here we have an example, and we're going to see how this works out using the distributive property. So Dina and Maura each wrote an expression for the perimeter of the rectangle. Are these expressions correct? Are they equivalent? So this is the perimeter of the rectangle. Now I know you guys are used to seeing regular numbers here, but now we're going to start using some expressions to represent the various sides. The one thing that we know about rectangular prisms that this side and this side are congruent. So that means they're the same. So this perimeter, this side is also going to be 2x plus 1. Same as over here. So that makes this side is congruent with this side, and I'm going to write it on the inside for now. So this is x plus 5. Okay? So these two are congruent. They're the same. These two are congruent. They're the same. So if you simply took all of these and added all 4 sides, because remember perimeter equals, okay, all 4 sides added together. So should put side plus side plus side plus side. That equals 4s, because there's 4 s's, right? So 4 times s. So let's take a look here at what we've done. We'll start with Dina's first. Okay. So Dina has said that 2 times 2x plus 1. So the 2x plus 1 has to do with this right here, and there's two sides. Then she added x plus 5, and she says there's two of them, so that's why we have the 2 here. So if we multiply these two, that's what we get. So Dina's seems to check out. But now let's go ahead and let's check out Maura's. Well, I look at the 6, I don't see anything with 6 sides, so that's not making sense. I have an x plus 2, I don't see anything over here at x plus 2, so how does Maura get to here? So what we have to do is we got to look to see if they're both equivalent to each other. So in essence, we kind of have to solve them. So if on the other slide I showed you about the distributive property, we're going to take the 6 times the x, so that's 6x. And then we're going to do 6 times 2, that's 12. And then we're going to use this symbol here, we're going to use the addition. So when we simplify this, that's what we get. But that still doesn't look like what's going on here. So let's go ahead and do the same thing. So 2 times 2x, that's 4x, plus 2 times 1, so that's 2. I'm going to bring down my addition sign, plus. 2 times x is 2x, so I multiplied those. And then 2 times 5 plus 10. I want to talk about like terms. Now what that means, and you're not really going to see it in the book explained very well, is that means that I have to find terms. So like y is a term, and 7 is a term, and 7y is a term, and so forth, okay? I have to find terms that are alike to each other. So if I have this expression where I have, let's say, y plus 7 plus 3y minus 4. What I have to do is I have to look, first thing, using either the commutative or the associative properties, I have to rearrange. Now I also have to be careful because this is a minus. So if I look, when you look for like terms, look at the variable. So I have y's there. So these two are alike. So I'm going to regroup that, and I'm going to go y plus 3y. Okay? And then that's going to leave me with a plus 7 minus 4. Now these are constants. So the 7 and the 4, they're like terms. These have the y's, so they're like terms. So what I want you to remember, though, is how many y's do we have right here? Well, we have one y. It's not written. Because if you look, 1 times y is still y. So 1 plus 3 is 4, 4y, and then 7 minus 4 is 3, so that's going to be plus 3. So we're going to have to gain more experience. I'll talk more about this in class, but we need to pay attention to like terms. So coming back here, we're going to do the same thing. We're going to find the like terms. So 4x and 2x are like. So I'm going to rewrite this now using the associative property. 4x plus 2x. I'm going to group those together. And then I have a plus 2 and a plus 10. So plus 2 plus 10. And I want to group those together. So I have 4x plus 2x is 6x because they're like, plus 2 plus 10 is 12. So now the question is 6x plus 12 the same as 6x plus 12? And the answer is yes. So both Maura and Dina were able to find the perimeter by using the expressions. We've looked at the commutative property. We've looked at the associative property of addition. We've started the beginnings of looking at the distributive property. We've gone and taken a look at like terms. This is going to be another thing that's going to be very important for us. And then we used an example to see whether these expressions were equivalent or not. So this is the beginning of our algebraic expressions that we're going to start working on. And I hope this helps you out. Come back to this and use this quite frequently.